All right, continuing on with our series on Lewis structures, specifically the Lewis structures from the practice problems on Moodle for test one. This one was giving some people some problems, only 3 atoms though, so certainly tractable. If I look at this structure, I don't really have to guess at what the central atom is going to be in this case. It's got to be iodine, but I know I have 3 iodine molecules, so I'm just going to go ahead and attach another, iodine atoms. I'm just going to go ahead and attach the other 2. So I've got to at least have something sort of like what I've drawn here. And if I think about how many valence electrons iodine comes in to this molecule with, it's a halogen, and like all halogens, it will come in with 7 valence electrons. You can count on your periodic table just to confirm that. So I've got 7 electrons from each of my 3 iodine atoms, which is going to give me a total of 21 here. But let's not forget the very important point that this is a charged species. It's anion. It's an anion, which means it's got an extra electron than you might have expected. So we need to tally that. So we need to take that into account, meaning we have a total of 22 electrons that we have to put into our Lewis structure here. I've obviously already accounted for at least 1 bond between each of the iodine pairs, and every bond comes with 2 electrons, so I've got a total of 4 electrons already in my diagram, and so that means I've got 18 electrons left to keep putting in other places. And as the rules go, we're going to satisfy octets on all of the outer atoms first. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, with apologies for the messiness of those electrons. I've just accounted for 12 electrons, which means I've still got 6 left over. So I've got 6 electrons I still have to put in places, and the rules say if you've got them left over, put them on the central atom. So I'll put a pair right here, I'll put another pair over here, and I'll put another pair just down here. Doesn't really matter where those pairs go as long as they're on that central atom. So I'll fill all those electrons in. They're all there now. And so now I should think about whether this structure is correct, or I should really put some Lewis, some formal charges on this Lewis structure. The other thing I might want to do, and in general I would expect you all to do, is if your molecule has a charge on it, so if it's an actually charged molecule, you want to indicate that by containing your Lewis structure in some square brackets and just noting the charge right outside those square brackets. That's useful to remind not only yourself, but anyone reading your work that you have accounted for the fact that this is an anion. And an anion is legitimately a very different thing than the neutral version of whatever you would have. So let's think about formal charges on all of our atoms and see how good we're doing. Each of the iodine atoms on either side, over here on the left and over here on the right, is identical, so I really only need to think about 1. And like I've shown up here, iodine comes in with 7 valence electrons, and so I really just need to count how many electrons they have as drawn. So I've got 1, 2 in that pair, 2 in this pair, and 2 in this pair. That's a total of 6, plus 1 from the bond, because this bond is going to be shared amongst the 2 atoms that it's connecting. So that's 6 plus that 1 gives me 7. 7 valence electrons, 7 in this diagram. 7 minus 7 is 0. And so I know I've got 0 on both sides here, and I know that zeros are good. So this is looking good so far. If I look at my central atom here, same calculation. It's also iodine, so it comes in with 7 valence electrons. I see 2 here, 2 here, 2 here. So just like the other iodine atoms, we've got 3 pairs. That's a total of 6. But this iodine atom's got 1 from this bond and 1 from that other bond as well. So it actually sums up to 8 for this iodine. So 7 valence electrons minus 8 that it has in this diagram right now gives me a formal charge of -1. Now, as I said before, -1s aren't quite as nice as zeros in terms of as formal charges go, but there's an important point. And the important point in this structure is that when you take a look at all of the formal charges that you've come up with for your atoms, they have to sum to whatever the actual charge is for the molecule. So no matter what you do, you're never going to get all zeros here because you actually have a charge on your molecule. There are too many electrons relative to the number of protons in this system, so we're never going to get all zeros, and that's okay. So this structure right here works for me If I look at the central atom here, I see 5 electron domains, so I'm imagining a trigonal bipyramidal system here. And as we learned in class, if I've got to put electron pairs in my domains, these would probably be in a plane, a trigonal plane around the center of the iodine, and one of the iodines would be going straight up, the other iodine would be going straight down. So I'm predicting a linear molecule here, even though we've got a lot going on in terms of electron domain geometries. Yeah, all kinds of interesting chemistry going on there. If you have any questions, let me know.